right, thanks for tuning in. Someone asked me the other day. They said, Jeremiah, I have my power bill. I want to only produce as much energy as I need for my yearly usage. It's a good idea. You don't want to overproduce. I think it's a good idea, even if somebody else is putting in the solar for you, to get your head around exactly what you're going to be producing per year. And also, if you're doing other energy upgrades, insulation, air sealing, thermostats, you want to be aware of how much you're using and making sure you're not overproduce. It's a common misconception that that the utility company will pay you if you overproduce, but it's just not true. And sometimes you get penalized for it, depending on where you live. We have a couple of assumptions. One, 5,000 kilowatt hours per year, just a number I picked out. It's actually pretty low for the U.S. It's actually less than half of average homeowner, but you guys lose less because you pay attention. 250 watt modules, just a number that we use. And then in Pennsylvania, we have a thing called sun hours. You have a different amount of sun if you're in Pennsylvania versus Arizona versus California or Alaska. And if you go to the National Renewable Energies Laboratory, they can tell you, depending on where you live, what your sun hours are going to be. So you should know that. Yeah, and you need to know for these calculations. 20% loss. It's a pretty average number. That's not shading losses because I don't know how many trees you have, but that's assuming that we have open sun, but that every time the modules touch, inverters, all these different things have some losses involved, and we want to be aware of that. All right, so we're gonna go ahead and start that. We have 5,000 kilowatt hours per year. And we're going to be dividing that by 365 days per year. Okay. Put the little division sign. All right. So that's going to give us 13.7 kilowatts hours. So kilowatt hours per day. So we divided out to 365. We're still the kilowatt hours. Those years cancel out if you can do that sort of a math. But so we go from there. So now we have 13.7 kilowatt hours per day. But we need to make the system a little bit larger because of those losses. So after the 20%, we have 80% left. So you divide it by that. Put that little line so we don't forget. And from there, we get 17.125. All right, kilowatt hours per day. All right, so 17.125 kilowatt hours per day. The units stay the same. So then. All right, so we have 17.125 kilowatt hours per day, and we're going to divide that by 4.2 hours per day. All right, the reason we do that is because if you remember, that's how many. That's what we use in Pennsylvania. That 4.2 hours per day is a pretty common number. We use different areas. It might be 6 in California. It might be less in Alaska or Maine. But we need to account for that because of where we are. So that figure, we then get 4.077 kilowatts. All right, or we're just going to go ahead and equal that, about 4,000 watts, right? Because we're doing the kilowatts to watts. We just have to change those numbers. So we take that 4,000. You take that 4,000 divided by 250. Don't forget the units. And from there, we get 16. All right, this thing's failing me. All right, so we're going to have 16 modules total from that number. All right, there you go. All right, so 16 modules is what we're going to want total for this array. So you also notice, if you go through and do the math on your own, if you change this 5,000 figure, if you change the 5,000 figure down to 4,000, it's going to end up, you use a lot less modules. You need a lot less. So it's a good idea to try and use as little as possible. If you have any questions, feel free to go ahead and post or email me directly. Thanks for tuning in. Bye.